I'm just gonna go to a whiteboard if that's all right.
Okay.
And so if we're doing inference with proportions, let's see here, this. See how thick this is. So we've got, if we're doing confidence intervals, so we got p hat plus or minus z, right? And the square root of p hat, and I'll just do 1 minus p hat over n. So whenever we're trying to find margin of error, that is the, I'll put a blue box. This is the margin of error, whatever's to the right of that plus and minus. So when you're like, if you're using StatCrunch and it just gives you essentially the confidence interval, right, the low and the high, you can find the margin of error by, you know, let's say it's between 5 and 9, right? Let's say that was the confidence interval. It's between 5 and 9, or let's say it's 50% and 90%, whatever it is. You can just find the whole thing and divide it by 2, and that's your margin of error, plus or minus. Or if you're using the formula, you use this. So do you have an example that you were looking at that from one of your assignments, or?
Yeah, let me pull it up really quick.
Cool. And then we can, yeah.
So the example I was working on, I guess it's not a margin of error, but more assuming what n would be based on confidence percentages.
So so sample size required, that one?
Yes, that's my problem.
Okay, cool. Well, how about we do that one?
Okay.
Does that, what I did there make sense as far as the margin of error part, is this right part?
Yeah, that does.
So in your formula sheet, like I even give you the numbers for Z, that like if it's 90%, 95, or 99, those are typically the ones we use.
That's the 1.96 or 2.57.
Yeah, very
yeah,
good.
that makes sense.
Yep. And then, so how about this? I'm going to go ahead and share the formula sheet, and we'll go through that calculation. How's that sound? For sample size required.
Yeah.
Let's see. Get this loaded here. Hold on. All right. I think this is. So when you're doing these, I mean, the formula sheet can be handy, but honestly, after you've done a couple of the regular inference ones, I would suggest using StatCrunch just for speed. But for this one, you kind of need the formula for the sample size required. So I'm going to zoom this in. Is that, can you, oops, not quite that big.
Yeah,
Does that look okay?
Nice.
Okay, great. So if we go to the very bottom, we have these two formulas. Sample size needed, where E is the maximum error estimate. So that's like that's like the margin of error, how far off. So what was your example?
The example in the homework is a programmer needs help developing new software. They're looking to find the sample size to be 99% confident that his estimate is in error by no more than 2 percentage points.
All right, cool. So if we know in general, like what's the they're trying to figure out what's the error, is it the, what are they measuring again for these computers? I can't remember, sorry.
Let's see.
They're measuring the defects or something like that.
Estimate the percentage of computers that will use a new operating system.
Okay, yeah, so let's say traditionally we know, I don't know, 10% of computers are going to need a new operating system that get turned in, let's say, for new, reconditioning or whatever. If you had a historical data that gave you an idea of what P would be, you can put that in there. But if you don't know, in this case we don't know, you just use 0.5. It's just like, we'll just pick the middle. Because if you think about this calculation, N, I'm going to make this not so thick, hopefully. N equals, And so if we're not sure, we just say 0.5, and then 1 minus 0.5 is 0.5. So that part of the calculation is just going to be 0.25. Well, let's say it was 40%. Then 0.4 times 0.6 is 0.24. Not a big deal, is it? It doesn't change it a lot. Or 0.3 times 0.7 is 0.21. So this does adjust if you have some prior knowledge, like this is the kind of level we're looking at historically. But if they don't give that to you, just use 0.5. And then it said, what level of confidence? 99, was it?
Right.
And then what's
Yes.
the Z multiplier for a 99%? Well, I've actually gotten it written right here, right? So 2.575 is right up here.
That's what I have.
Cool. 2.575. Oops, sorry. And then over error, you said what, 2%?
2 percentage points, yeah.
Yep, so 0.02. And then we square that. So if we're gonna do that on a calculator, do you have your calculator handy?
I do.
All right, so let's do this. Take 2.575 divided by 0.02, and what do you get there?
I have 128.75.
Nice. Now square that number. And then take that number times essentially 0.25, because that's what 0.5 times 0.5 is. And what do you get for n?
Let's see. So 128.75 squared is 16,576 and
Cool.
5,625.
Now take that times, yep, take that times 0.25, and what do you get?
Let's see. I have 4,144.
4,144. Is there any decimal in that?
Yeah, 0.1406.
All right, so does that look right on the screen?
Yes.
4,144.1406, does that look good?
That's what I have, yes.
Yep, so the sample size required, well, if we can't have partial trials, right? Because it's a discrete thing, 1, 2, 3, 4, or computers, right? 1, 2, 3, 4. So 4,144 would not quite be enough. We actually need to go 4,145 to make sure we accommodate for this little bit. So your answer in StatCrunch, or in my stat lab, would be 4,145 would be the sample size required to get this level of accuracy and this level of confidence. How's that sound?
Okay, yeah, that makes sense.
Yeah, so a couple little tricky things there, right? But especially the remembering at the very last step, if there's anything above any decimal part, we got to go one more to make sure we're accurate enough. And
that makes a lot
that's
more
a lot
sense.
of computers.
Yeah.
Yeah. So think about when they do polling, like for candidates and elections and stuff. Their margin of error is typically around 3%. So, and they usually don't go to 99% confidence, they go to 95% confidence. You'll even see those calculations when you look at publications online and stuff. So this number changes to 1.96. This number here changes to 0.03. And then that makes this number here about 1,000. So you only need about a fourth as many sample size to get 95% confidence and a 3% margin of error. Now, if you're running a polling agency, that is a lot more cost effective than, but if you wanted to be super accurate, you wanted to be only more, I haven't really seen a poll ever do this, but if somebody wanted to really be more accurate with their polling, they would quadruple the number of people they find and hopefully find a very representative sample, and then they can
Mhm.
get their margin of error down to 2% and have 99% confidence. But you just don't see that very often. But
Right. I did.
cool.
Yeah, I did polling for the census last year, so I
Oh
forget what our
wow.
margin of error was. Yeah.
That if you could find that, I'd be very interested in that. Because when they say census, census is when we try to count everything in the population. Well,
Right.
it's an attempted census, right? We can't really
It is
count
very attempted.
everything.
Yes.
It's an attempted census, which is a big undertaking. An attempted census is a big job. But this is why, in general, most people who don't have unlimited funds, like the United States government, to go do
Mhm.
to go do a census, companies that want to like test their products or do marketing research or whatever, they use samples from populations and then make an inference. Now they could be wrong. Like we're only 99% confident that the true proportion is between above, right? That's what this would, we went up and did 4,000 computers, but we're not going to try to test every computer everywhere. Okay, that would be a census of all computers would be ridiculous, right?
Right.
So this is the power of statistics. It allows us to use samples to make inferences to populations with a pretty high degree of accuracy. Now, that's why we always say level of confidence, margin of error. It's not an absolute. There are some times we're going to miss the mark, but most of the time it's pretty close and it works.
Yeah.
And yeah. And then have you done much on the means chapter yet? Inference with means? Remember doing
Yeah, I
that?
got through all the missing assignments and this week's assignments last night, so I'm pretty caught
Nice.
up
Good
now.
work. That is amazing. Nice job. So that, remember the T distribution? So funny story behind that is it's a true story. The dude that came up with the T distribution, he was like, man, I would love to not have to sample so many and still be pretty confident of my results, right? That's a great, and he
Hmm.
worked for the Guinness Brewery. And so his name was Gossett. And Gossett, he'd have, I don't want to have to test every batch. Like, this takes time and money. And I need a smaller sample to tell me if quality is good or bad, right? So he
Something more
came up
efficient.
with, yeah. So he threw a bunch of like 1 to 100 into a basket, right? And he knew the mean, he knew the standard deviation, and he pretended like that's the population. And then he would randomly like, all right, I'm just gonna pull up like 3 numbers. You can find the mean and standard deviation of that. Throw them back in and pull out 3 more. Do it again. Pull out 3 more. Do it again. And he kept plotting those, and it came out to be almost a normal distribution. Then he said, well, what if I do 4? What if I do 5? What if I do 6? And that's why that T distribution keeps changing with each sample size. That's what we call our degrees of freedom. And he's like, this works. I mean, I can make inferences. The larger my sample, the more accurate it is, the less spread I need to account for. So then he was like, he told Guinness Brewery, like, this is amazing. This is going to help the world with everything. Like anybody does manufacturing, anybody does any quality control. But Guinness said, no, this is now a trade secret of ours. We have an advantage over our competition. And he begged him. He's like, this has really nothing to do with beer. Okay. This has more to do with like how to make things more efficient and better and all these things. So they finally relented and said, okay, you can publish, but you cannot use our name and you cannot use your name. So our competitors don't know we're kind of using this. So that's why it's called the student's T distribution. That's what he came up with instead of the Gossett
All right.
distribution. Isn't that
Yeah.
cool? I love telling
Yeah,
the
that's
story.
really
So
nice.
thanks for letting me tell it. I think you had a choice, right? So that's a really cool thing about the T distribution. And as T, or the degrees of freedom, keep going up, it becomes approximately normal. It turns into the normal distribution.
Right.
Yeah, cool. Did you have any other ones, Matt, that you've been working on that you need a little
Um,
help with?
I think my general question for StatCrunch is when it comes to uh, standard deviation, it is always squaring the n and sample standard deviation, correct?
Yeah. Um, so for instance, when you just do basic what we call one variable statistics. The formula
Right.
that you did back in chapter 2 or whatever, you show a few examples by hand, but pretty much let the software take care of it, is pretty much you're finding the mean, you're finding the difference between each data point from the mean, squaring those differences, adding them all up and dividing by n minus 1. That's the variance. The square root of that is the standard deviation. So when you're doing, especially when you're on StatCrunch, you type the data in, it automatically does that calculation. It puts these numbers in for like S, right? That's your sample standard deviations and or variances here, which is in the variances chapter. And then it just uses those numbers. Now, the interesting thing about StatCrunch is finding degrees of freedom, like in these formulas. We have a pretty rudimentary way of doing it, like this one, n1 plus n2 minus 2. Sample size 1 plus sample size 2 minus 2. There are more complex and accurate ways to do that, which we do not cover in this class, and the software actually deals with this for us. And so when you might see a really weird degrees of freedom when you do your StatCrunch stuff, just know they're using a different calculation. But in the big scheme of things, it's almost a negligible difference. But this is why sometimes you need StatCrunch to get the correct answer on MyStatLab, because it's assuming you have access to that technology and that level of accuracy. These by hand methods aren't good enough for what they're looking for. So I kind of like that, because a lot of staff or a lot of faculty will not even show these formulas at all, or barely at all. Once you kind of get the idea that everything, all these confidence intervals are just a sample plus or minus a margin of error, and it's just different ways of doing that. That's all I really want you to see. What things are affecting what. And then after that, we let the software do the heavy lifting for us. But I think there is some value at least seeing what's being added and subtracted, multiplied and divided here. Where do these numbers go? Just get a framework for it and then go from there. So did I answer your question at all? I'm sorry if I didn't.
Oh, there you are.
Oh, sorry. Did I answer your question at all?
Yes, you did.
Okay. Sorry, I kind of went off there, but it's very nice interacting with a student. I really appreciate this.
I learn much better when I'm one-on-one, so this helps a lot.
Cool.
It took me forever to realize that using StatCrunch may be better than doing it all on hand.
Yes. So I think you're one of those students who will endure much pain and anguish, right? And go through that. And I'm sorry, because you're a good student. And but then eventually you're like, okay, why am I doing this again? I could just click these three, I click, and it does the same thing. How about if I just do that now?
Yeah.
And I would strongly encourage that. So there's always, for me, it's a balancing act. Do I even use these formulas at all? Do I just say you have to only use StatCrunch? The problem I think sometimes with just going immediately to StatCrunch is you don't really know what's going on. You're just kind of hitting some buttons and it's pumping some numbers out, and you're like, wait, where'd they get these and how they get these? But you now know very well what that thing is spitting out at you and how it kind of got there, right?
Right. No, the context of using the formulas helps explain what I'm getting out of StatCrunch.
Yes. So I'm telling you right now, this is it. Once you do this chapter 7 through 9 stuff, the rest of the chapters are pretty easy. And then all you have left is your project to do, and that's your own choosing, and it can be really applicable, and it's kind of fun.
Yeah.
So once you take this test over chapter 7 through 9, it's really downhill after that.
All right.
Yeah. So this is you've done the hard work, the heavy lifting. So good job.
Thank you. Then our discussion it is just a discussion for week 5, correct?
Yeah, let me go in. Let's look at the course content here. And so for week 5, yep, that was the inference with proportions, right? And then week 6 is just inference with deviations, and then the test. And so when I send out the announcement, probably Well, I'm gonna send an announcement out today for the office hour tomorrow.
Okay.
I will also put in there, yes, the homework for deviations, those 3 online homework sections is due tomorrow, the 5th of October. But then I will say the test, I'll give an extra day for the exam, kind of like I did last time. Remember that?
Right.
So, and I may even give 2 days because the next stuff is not nearly as intense. You can rip through chapter 10 and 11 pretty fast, and then you start working on your final project. So I may even give all the way until Friday, possibly. The only bad thing is as soon as I give another day, what do you think everybody does?
Waits that
They
day.
just, they just
Yeah.
which I don't want. But I understand this has kind of been intense and stuff. So I'm going to put that in my announcement that I'm going to be flexible on that exam time. Okay, frame.
All
How's
right.
that sound?
Yeah. Thank you.
Cool. You bet. And I'm looking in there right now. So I've got the old exams out there to look at, which I highly recommend. Did you do that for the previous exams?
Yes, I did.
All right, cool. And was that helpful?
Yeah, I like those a
Awesome.
lot.
Yeah. All right, great. And I'm looking right now. Yep, I even have the one from 2020 out there now. So I got the most recent one from last year. I've got a new one that I'm giving you this semester, but yeah.
Perfect.
Cool. Yeah, we're getting. I mean, I literally only have one more folder to open up, which I will do probably on Wednesday or Thursday this week, and then that's it. So then, if you do your final project discussion, like here's my idea, you post a little video of your idea,
Hmm.
and the reason I do that is so people can, kind of see you and present it, and then then the class and myself can give you feedback about your idea and kind of get it refined. And um, sometimes people are like, I can't do that idea at all, and that's fine. They do something else just to get you ready for the final project. Then you write up your final project, you make another video over it, and then the only last thing to do after that is to just take the comprehensive final exam, which is going to be administered the same way, and that'll be over the whole course. But
Okay.
primarily, it'll be most weighted on what's chapters 7 through 9. So if you're doing good on chapter 7 through 9 stuff, you're gonna do great in the final.
Awesome.
Sweet. All right. Have I answered your questions, Matt? What do you think?
Yes, that was really helpful. I got everything I
All right.
was struggling on figured out.
Awesome. Well, you keep up the good work.
Oh,
If
then
you
I was.
want, if you want to do a test review like tomorrow morning even, or Wednesday or Thursday, let me know. If you want to do something before you take
Okay.
your exam. How's that sound?
I will try to figure something out between work, but yeah, I will let you know.
I can do them. I can do them in the some evenings too. So that's fine. I had somebody initially want one like at 5 o'clock today, if they're going to be an airplane. Anyway, it's going to work out fine for them to. They're going to come tomorrow morning. But if you need one in the evening, like I know you'd suggested this weekend. I'm sorry that didn't work that particular time. We had a parents' day for my son at Iowa State, and we were up there doing that. So in his fraternity. But anyway, I can do nights too usually.
Okay, awesome. Oh, then I was
All
looking through
right.
my census notes when I was
Oh yeah.
taking them. I believe we got 99% of our census.
Nice.
Then I think our margin of error was somewhere between 5 to 8%.
Okay. Yeah, I mean, think about if we just use statistical methods to count everybody in the United States. They'd say, okay, the density of Grimes is, we'll figure it out for this little part of Grimes, or we'll take a diverse sample geographically and find the density per square block or whatever, and then infer what the population is. Okay.
Right.
That wouldn't
The
probably be the
hard thing
best,
was,
but
yeah.
It'd be a
The hard
guess.
thing is that we go to every house. It is not every person. So we were more or less
Yes.
counting houses and checking whether they're valid addresses, whether there's a resident in there. Then you go in to ask, and that's if the person actually responds to the census, their name, age.
My mom actually did that job this last time. She worked at
It's
the census.
It's not bad. I'm glad it's every 10 years.
I think she is too. I think maybe this will be her last one. She's in her 70s, but she did the last one too. I think she was more in the central office dealing with the paperwork stuff. But anyway, it's kind of a neat process. And now that you've taken stats, you probably even more appreciate approaching things this way instead of trying to do a census all the time for everything. That would be really slow and cumbersome and overkill probably for most applications.
Right.
All right. Well, Matt, you're doing great in this class. Thank you so much for requesting office hours like this. I think this recording will hopefully help some people, and I'll post it. And well, maybe if you have any questions, I'll be back on tomorrow morning, or just shoot me another message to set one of these up.
All right. Sounds good. Thanks so much.
You bet. Talk to you later.
Bye.
Bye.